I'm deeply honoured to be in this esteemed company. Thank you very much to the Academy for giving me this opportunity. I'm Ian Reid. A little bit about me to start with. I grew up in Perth and went to University of Western Australia, and then progressed to Oxford. Cecil Rhodes was very good to me, but I intended to come back to Australia straight away. Ended up staying for 25 years. And came back 4 years ago to be a Professor of Computer Science at University of Adelaide. This slide is desperate to get on to the next one, isn't it? So what I do is research in computer vision and robotics. So let's go with this slide. So I'm so sorry. So what I aim to do is trying to make computers and robots see. We're trying to use study of mathematics and algorithms, processing images and video to infer scene knowledge about a scene. And computer vision really encompasses a whole bunch of areas: computer graphics, probability, algorithms and representations, projective geometry, and optimization. I noticed in the brief bio of me, I'll give you an anecdote. I spent far too long in England, perhaps, and well before Hawkeye existed and there was goal line technology in the World Cup and so forth. There's this reference here that says, "I solved refereeing issues in sport." This actually refers to something you discover very quickly when you live in England for a long time that the single most significant sporting event in England was winning the World Cup in 1966. And we were working on projective geometry. We were trying to understand what was going on in a pair of images without knowing where the cameras had been. And so we obtained some footage from 1966 and showed, unfortunately for the English supporters, that Geoff Hurst's crucial second goal, England's third in the final, did not in fact cross the line. I see a Scot nodding down here. So that was an example of using probability theory and projective geometry in computer vision. But if we've learnt one thing in computer vision over the last 15 to 20 years, it's the importance of leveraging prior knowledge. And machine learning gives us a way to leverage prior knowledge without having to hand code it. Machine learning, looking at lots and lots of data, has revolutionised our field and enabled us to make computers and robots that can see. Robots fundamentally are blind. Finally, I can go onto this slide. To be able to operate in a dynamic and uncertain environment, autonomous systems must be able to sense and understand. They must be able to perceive their surroundings. And there's a lot of advantages to using cameras, to using computer vision to do that. Cameras are expensive and ubiquitous. They convey a vast amount of data about the world in real time. We live in a visual world. We've created a world around us that has things like signs and lettering and colours that we can use to understand the world. Typically, cameras are passive and low power consumption, and there's this promise of flexibility, but they come with a whole bunch of problems as well. Vast amount of data, much of it is redundant. Information is lost. When you project from a 3D world down onto a 2D image, you lose a lot of information. And we don't really have a clear understanding of how the human visual system works. And I've touched already on this difficulty of representing or using prior knowledge, which is clearly something that humans are doing all of the time. But robotic vision is potentially a transformative technology for Australia and for the world, because robots are blind, and so we've seen a revolution using robots in, say, the car industry, where you can take people out and you can manufacture an environment in which a robot can operate without having to know what it's doing. It can just do the same thing over and over again, and you can program it to do something different at a later date. But if you want a robot to operate in an environment that is fundamentally uncertain, it must be able to perceive that environment. And we've already seen some great examples from Eduardo Nebo talking about the work that they've done at ACFR. I fundamentally concentrate on computer vision as a sense because of its flexibility, because of its ubiquity and so forth, and working in the Centre of Excellence on robotic vision. We're passionate about autonomous infrastructure inspection, self-driving cars, robotic-assisted collaborative manufacturing, and taking robots into construction. All of these areas, and robots in agriculture, are characterised by an uncertain environment that you must be able to sense. Vision for my role in ATSE. Well, in particular, I think it's really important if there is going to be, and surely there will be, a revolution in self-driving cars, in automation, in manufacturing, in automation in agriculture and so forth. It's really important that there are strong advocates for these technologies, people who understand these technologies. I see a role for advocacy and education in machine learning and robotics and computer vision in a world where the public's perception of robotics is governed by what they see in sci-fi, being able to say, actually, no, it doesn't work like that, and here are the limitations to what you've seen on this news report, and so forth. I also think that the vision and robotics, computer vision that I work on and robotics, came out of artificial intelligence research in the 1950s and 1960s and really diverged. And one of the reasons that they diverged was that roboticists wanted a sense that worked. And computer vision didn't work and hasn't worked until around about 15 years ago. And now we have much better algorithms for doing object recognition, for building maps of the environment, and so forth. And so connecting those two fields back together is part of my mission. It's part of the mission of my colleagues in the Centre of Excellence. I'm already serving on the Academy of Sciences National Committee for Information and Communication Sciences, and together this group with ATSE is developing a strategic plan for ITC in Australia, and I'm serving on a working group of the future of autonomous systems. And I think that these are very important things to be able to inform the public of what really is the case and what is science fiction and how we can move together to make these technologies work for us. Thank you very much.